Okay, this is the last part of Unit 12, and I'm hoping this will be much quicker than everything else, especially because we've already talked about this with area. We talked about dimension change, so we're going to look more at volume today. And so let's start with just getting the original volume of that rectangular prism on the left. And so the original volume of that prism is 64, because it's 8 times 2 times 4. So the original volume is 64, and we're definitely not filling in this whole thing. We're just going to do maybe a couple of examples in each. If the dimensions were twice as long, okay, I'll just go ahead and give you that number. The new volume would be 512. Okay, and if I were to do the new volume of 512 over the old volume of 64, then that new scale factor would be 8 to 1. You can either write that with the colon, or you can write that as a fraction. You'll see me write it both ways. Okay, but notice our original dimensions were 2 to 1 scale factor. Our new scale factor for the volume is 8 to 1. Okay, and just like with area, we're going to see a pattern here. So let's go down to if it was 4 times as long. So if the dimensions were 4 times as long, the new volume would be 4,096. Okay, and if you did 4,096 over 64, you would get 64 to 1. Okay, so real quick, I'll just go ahead and tell you what the pattern is if you don't already see it. Just thinking back to area, remember with area, if you squared the dimension scale factor, then you got the area scale factor. With volume, if you cube the original scale factor, then you get the volume scale factor. So think about with area, those are units squared. Well, volume is units cubed. And so whatever the original dimension scale factor is, you would cube it. Okay, so let's go back down here. This is where we're talking about back to area. So just to show you the difference here, if I were to get the surface area, so if we're talking about surface area or lateral area of these figures, it's going to be the same thing because it's both area. So just to save you time here, the original surface area would be 112. Okay, and if both dimensions were twice as long, then the new surface area would be 448. And so the new scale factor is 4 to 1. So we saw that last unit, that whenever you have the scale factor, so 2 to 1, if you square both of those numbers, then that's where that 4 to 1 comes from. Okay, so this is kind of what these examples would look like. But here, in this little box that I'm putting a rectangle around right now, that is what's happening with all of these scale factors. And so if you take your original scale factor of your sides, to get the ratio of the surface area, you would square those. So you would do 2 squared and 3 squared. To get the ratio of the volumes, you would cube it. So 2 cubed, 3 cubed, and that's where 827 would come from. So this next section, by what factor would the volume change if the dimensions of a pyramid, so notice here we're talking volume, so if they were quadrupled, that would be times 4. So if that's what my dimensions are doing, they're being multiplied by 4, to get how my volume is changing, I'm going to cube it. And 4 cubed is 64. Okay, if my original dimensions were being halved, so my original scale factor is 1/2. To get my volume dimension scale factor, I'm going to cube that, cube both numbers, and that would be 1 to 8. If the original dimensions were being tripled, if I cube that, the effect on my volume is it's going to be times 27. So notice on number 2, it's asking by what factor would your lateral area. So here we're talking area, and area is something that's squared. Okay, so if it was being quadrupled, so that would be times 4, then I'm going to square that, and then that would be 16 times. If it was being halved originally, if I square that, that would be 1 over 4, and if it's being tripled originally and I square that, that would be times 9. Okay, number 3, the volume of a cone is 36 millimeters cubed. Suppose the dimensions were multiplied by 4. So the dimensions are being multiplied by 4, and notice here we're talking volume. And then we want to know the new volume. Well, to be able to find the new volume, we need to know the volume scale factor. So if the dimensions are being multiplied by 4, I'm going to cube that. And so my volume scale factor is 64, and I'm going to go ahead and just put that over 1 because I need to find a new volume, and so I need to set up a little proportion here. Now you could do this without setting up a proportion because you can probably figure out that you need to multiply that, but I'm just going to go ahead and do it. So it says the volume of a cone is 36, and the dimensions are being multiplied by 4. So this is something that's getting bigger. So I'm going to put this 36 down here with the 1 because that's the small. I'm going to throw my x up top. And if you cross multiply here, you get x as being 2,304 millimeters cubed. I'm going to be really bad with putting units on this today, so just know that. Y'all's test doesn't have units on it anyway, so no big deal. Okay, B says if the old surface area, so here we're back to area, is 100, what is the new surface area? So again, we need to have our area scale factor here. So if the dimensions are being multiplied by 4, then I'm going to square that to get what my area is doing, which would be times 16. So I'm going to put that over 1 just so I can have a proportion. The old surface area is 100. This is getting bigger. So I'm going to throw that 100 down there with the 1. And if you cross multiply, then your new area would be 1,600 millimeters squared. Okay, number 4, two spheres have a radii of 4 and 10. Determine the surface area ratio and the volume ratio. Well, to be able to do that, we need to have the original ratio of the dimensions. So I'm going to do 4 divided by 10 so that I can simplify that. And that's 2 over 5. So if the dimensions are being changed by 2 to 5, then I'm going to square that. So if I square 2 over 5, I'm going to square that for my surface area ratio, which would be 4 over 25. And for my volume ratio, I am going to cube 2 over 5. So that would be 8 over 125. Number 5, two similar cones have volumes of 27 pi and 64 pi. And we need to find all these other ratios. So notice here it's giving you the volume. And so what we need to do is divide those so that we can get the ratio of the volumes. Okay, so if I do 27 over 64, the pi's are going to cancel. That doesn't go down anymore. Okay, so that is the scale factor of the volumes. So if we want to get what these original ratios were, think about how that volume scale factor was made. It was made by cubing numbers. And so I don't know how much y'all have done this in the past, but what we need to do is not take the square root of those numbers. We need to take the cubed root of those numbers. So we need to take the cubed root of these numbers so we can figure out what number was cubed to get to 27 and to 64. There's a button on your calculator. If you hit the button math, and then if you hit, I believe it's number 4. Let me get my calculator in front of me. So math, if you hit math 4, your cubed root will come up. And if you can type in 27, you'll see it's 3. And then do the same thing with 64. So math number 4 and 64, you'll see that the answer is 4. And so what we've just done is we've gotten our original scale factor. So when it says the height ratio, that would be 3 to 4. You can either write it with a colon or you can write it as a fraction. Okay, now we're talking about area ratio. So I'm going to square those two numbers because that's my original dimensions. So that would be 9 to 16. Okay, total area ratio, that's still area, so that's still 9 to 16. And then volume ratio, I'm going to take what's happening to my dimensions and I'm going to cube it. So that's going to be 3 cubed well, we already had that from the beginning anyways. It was 27 over 64. You can either use the slash or you can use the colon. Okay, we're going to do a few more here and then we'll be done. So let's go to number 7. A cube's surface area. So notice here they're giving you the area, and another cube surface area is 150. The larger cube has a volume of 25. Whoa, sorry. Calculate the smaller. Sorry, that got cut off. That's the larger cube has a volume of 250 centimeters cubed. Calculate the smaller cube's volume. Okay, so notice here they're giving us the area, the areas of these two. So I'm going to divide these. So I'm going to do 54 over 150 so I can figure out what the scale factor of my sides are. And so if you simplify that, you get 9 over 25. Okay, that right there is your scale factor of your area. Okay, 9 over 25. So this, to be able to get the cube's volume, the new cube, then I need to know what the original scale factor was of the dimensions so that I can cube it. Okay, and so what I'm going to do here is I am going to, if this is basically this scale factor here was made by squaring numbers, okay, because remember we're talking area here. So I'm going to take the square root of these. So square root of 9 is 3, square root of 25 is 5. So 3 to 5, this is what was happening to my original dimensions. So now if I need to figure out what's happening to the volume, I can now cube that. So 3 cubed is 27, 5 cubed is 125. And now I can use that scale factor to find the new volume. So this says the larger cube has a volume of 250. So I'm going to put 250 down here with the 125 because that's the larger number. And then I'm going to throw the x up top. And so now when you cross multiply and divide, you get x as 54 centimeters cubed. All right, a few more here. And you know what, actually, these are all pretty similar. I'm going to go through here and I'm going to mark these answers for y'all. But I'm not going to talk through them because I just don't really feel like it's necessary. So number 1 here is C. Number 2 is J. Y'all can go back through and work these if you want. 3 is D. 4 is H. 5 is C. And don't worry about the last couple of slides because those are really simple questions.